Question number 20, I had asked you to just apply the formula lambda equals to h by mv, and you get
MV.
the yes. So velocity is anyway given in SI unit, so you don't need to change, substitute as it is, and you will get the answer. Next question is the mass of an electron is 9.1 into 10 power minus 31 grams. Even if it is not given, you know that. If its kinetic energy is given, calculate its wavelength. Yes, Arna, you have raised hand.
So we'll use the kinetic energy formula
Okay.
and we'll
You need to tell me the formula also. Yeah.
okay, half mv square 1 by 2 mv square
Okay.
v
Good.
equal
Then
v equal to 2 kinetic energy upon meter and half.
half you mean square root,
Yes.
power half, right? Okay. Then this is just the first step.
Yes.
From here,
Then we'll use the second formula and lambda equal to h upon mv.
right. Good. So what is required? First, wavelength is required, and wavelength you don't have directly related to kinetic energy. So from kinetic energy, you will get velocity, and from velocity, you will get lambda. Kinetic energy and velocity are interrelated. Kinetic energy is equal to half mv square. So from here, you will get velocity, and this velocity you will use as lambda is equal to h by mv. So h is known, mass is known, velocity you have calculated, you will get wavelength. Yes, you were saying
Sir,
something.
I use the same formula, but my
So
answer
we
was
can use the formula, sir, that wavelength is
my
equal
answer
to
is coming
h
out to be
by
something else.
root 2 me, root 2 m into energy.
Mm, yes, you can directly mix these two formulas. That is also acceptable
Yes.
if your teacher allows. Okay. Only in two cases. If your teacher allows, then and in MCQ type questions, you can mix these two. Okay. So that's fine.
Sir, how will we mix these two formulas?
Basically, you substitute the value of V calculated from here, because you know V is equal to square root twice of kinetic energy divided by M. Just substitute that here. So that is what
So, sir, is this not allowed, sir?
it is allowed if your teacher allows. A few teachers don't allow it.
Oh, okay, sir.
Okay. So that is something uh, if your teacher allows that, that's absolutely fine. If you
Okay,
mix,
sir.
this is the formula.
So, but if we write both the formulas first and then we substitute, so that at that point, no teacher can cut our marks, right?
No, in that case, it is absolutely fine. There is no way that teacher can say it is not allowed because you have used the standard formula. This
Okay,
is
sir.
not a standard formula. That's what I am saying. Okay. But if your teacher, and most of the teachers allow this, most of the teachers will allow this formula, mixing of these two. Okay. Then you use this formula directly, no problem. If someone was saying that the answer is not same as given in NCRT.
Yes, sir. Sir, I was just saying, sir, my answer is not coming out this. It was coming out to be 893.3, and in this one, it is given 896.7, 896, 8967. So,
8967 angstrom is the correct answer. If you are getting that, this is fine.
Sir, mine is
Okay.
coming 8120.
No, 8120 should not be there. There is some mistake, it means. If you are getting somewhere close to 8960, 8960 to 8970 angstrom, then it is correct. Somewhere, anything in between these two is correct answer. Means there is some calculation mistake.
सर
Yes.
सर मतलब आंसर्स हमारे मतलब जरूरी नहीं है कि सही हो.
If these are close, that's fine. Somewhere, and if it is, too distant from the answers given, then you should think about that there is some calculation mistake or your concepts are not clear. Okay? And send those questions to me on WhatsApp. What normally I do, the approach is that if you tell me, in between in haphazard way, I will have to go to that question and then we'll have to explain, then come back to the NCRT questions now, for example, if I am doing. and it disrupts the flow. That's why just send those questions to me so that I can prepare a presentation for that with all those questions, and we can discuss all those questions in sequence. Are you getting my point? Otherwise, you can discuss those questions, whatever questions you want to discuss in doubt class. So in doubt class, you can ask any question, I will answer them.
Sir,
That, yeah,
sir, you will arrange doubt class after we complete all the assignments.
yes, after you have done the assignments, after that I'll arrange the doubt.
Okay, sir.
Now the question is, what is the lowest value of n, means number of shell which can allow g orbital to exist. So you need to first write it, means s, p, d, f, g, h, like this: 0, 1, 2, 3, 4. Now you can give me answer. Arjun,
Sir, n should be 5 because we know that the number of orbitals would be equal to the the number of suborbits would be equal to the shell number. So the n should be 5. So may
okay,
I?
fine. Yes,
So value of n will be 5 because the value of L ranges from 0 to n minus 1.
right. That is the correct way to answer this one. You say that the subshells values are from 0 to n minus 1. So it is 0 to 5 minus 1. 4 is 0 to 5 minus 1. It means the n is 5. This is, if this question appears as subjective question, this is how you will write it. You will say the subshell values are from 0 to n minus 1, and as for g, the L is 4. Okay, that is n minus 1 is equal to 4, n is equal to 4 plus 1, that is 5. Yes,
सर जी की जगह एच हो सकता है क्वेश्चन
theoretically, if we are talking about theoretically, how many shells we have? We have 7 shells. In periodic table, the periods actually depict the shell number. So these periods, first, second, third, fourth, fifth, sixth, seventh. It means the elements which are shown here, hydrogen and helium, are in first shell. They will have only one shell. Then we have lithium, beryllium, boron, then carbon,
Carbon,
nitrogen,
oxygen,
oxygen,
fluorine.
fluorine. These will have two shells, means the valence electron will be in second shell. And so, so shell number actually says what is the valence shell. This period number is valence shell. So if it is n equals to 7, n equals to 7 means L can be from 0 to 6. 0 to 6 means 0, 1, 2, 3, 4, 5, 6 means S, P, D, F, G, H, and so on. Okay, so theoretically, yes, it can be asked theoretically. Next question. What transition in hydrogen spectrum would have the same wavelength as the Balmer transition n equal to 4 to n equals to 2? We have done this question during the theory class as well, but I included because this is very common question and you need to understand, and probably you need to memorize the answer also. There are two questions of this type. One is NCRT and one is another question, which I'll give you in the assignment. Okay, so for helium ion, if we are talking about, okay, n is equal to 4 to 2. So we can apply the formula of wave number and we get a value 3r by 4. For hydrogen atom, we can apply the same formula And we can equate it to 3r by 4 because it is given the wavelengths are same. Okay. Same wavelength means wave numbers will also be same. Lambda 1 is equal to lambda 2, that is 1 by lambda 1 is equal to 1 by lambda 2, that is nu 1 part equals to nu 2 part. So equate these two, and we will get 1 by n1 square minus 1 by n2 square equals to 3 by 4. And then we will have to do some hit and try. This is not very good question in that sense, because we have to do some hit and trial that what values of n1 and n2 will give us 3 by 4. This will be n1 1 and n2. These transition will be from n equals to 2 n equals to 1.
Sir, how do we do it and also like in what sense will we do here? So means what values will we apply hit and trial on?
Okay. Mathematically, if you know, suppose you have here this one has to be less than this one. Okay. Otherwise, it won't be positive. So for this to be positive, n1 has to be less than n2. So first, you need to understand that if you have 1 minus 1 by 2 square, the other one, if this is 1, this will be 2, 3, 4, etc. And if it is 2 square, you write 1 by 4. And if it is 1 minus 1 by 3 square, the difference you need to understand. Sorry. Here it will be 1 minus 1 by 4, that is 3 by 4. Here it will be 1 minus 1 by 9, that is 8 by 9. It means the value is increasing substantially. 8 by 9 is much greater than 3 by 4. So suppose you get a value, not 3 by 4 here, 1 by 2. And you get here value which is greater than 3 by 4. It means you don't need to consider further values for n1 equals to 1. It means you need to change n1. Are you getting me what I am saying? Because
yes, sir,
you have crossed 3 by 4. One value is less than 3 by 4, the other value is greater than 3 by 4. So it means there is no possibility you can get the value 3 by 4 by increasing n2. So in that case, start with n1 equals to 2, then n2 equals to 3, and do the same thing. If for n2 equals to 3 and n1 equals to 2, n2 equals to 3, you get value less than 3 by 4. Then yes, you can try the next one, that n1 2 and 2 equals to 4, because the value you have, this value is less than 3 by 4. So next value will be greater than that one. It might be 3 by 4. But if for this one you get value greater than 3 by 4, don't try this. It means this is not possible at all. So that's the hit and trial you do. And mostly the good part is that these type of questions have the very beginning values of starting values of n1 and n2 as answers. For example, here you can say 1 and 2 only. Okay. Another example is there in which n1 equals to 2 and n2 equals to 3 is the answer. Two questions are there in which 90%, more than 90% times this question appears, not the other one. Okay. So if you just memorize these values, 1 and 2, 90% chances that you will be able to do this question. Next question. Calculate the energy required for the process this. So this is ionization. Electron is going out of hydrogen-like species, helium plus. The ionization energy for hydrogen atom in ground state is given. You need to calculate the energy required for this one. Means n1 is equal to 1, n2 is equal to infinity. That's what you have to do. Because this is ionization, nothing else. And you will get the answer. These type of questions now, question number 42, 43, 44, these are, I would say, not chemistry questions, rather mathematics questions. Nothing related to chemistry except how many neutrons, how many protons, how many electrons are there normally in atom. Except that there is no chemistry. The entire question is actually mathematical calculation.
So these
sir,
type
can I
of
tell the
questions
question
come
for
in
this
exam.
question?
One by one, yes. Tell me what you are saying.
Sir, do these type of questions come in exam?
There is a possibility if this is in syllabus. Last year it was excluded from the syllabus. But this year there is no reason that it should be excluded because the classes are going on, regularly. So the chances are that uh, very little part will be out of syllabus this year.
But last year classes were also going regularly.
No,
Yes,
initially, very in many schools, classes were hampered because they didn't have the means, right? So for example, Microsoft Teams, etc. They had to buy or they had to get configured. There were a lot of problems. That's why these were, excluded. But this year, CBSE knows that schools are already prepared. Classes from the very beginning have started regularly, so there is no chance that syllabus will be reduced. Now, an element with mass number 81, the element is with mass number 81, contains 31.7% more neutrons as compared to protons.
Sir, we can say that let X be the number of protons.
Yes, so the neutrons equal to 131.7 by 100x.
Yes,
So we had to equate it with 81.
basically these type of questions are similar to what you have done in your 7th 8th standard, starting from 7th 8th standard, where it was that Raj is X years older than his father. After 5 years their ages will be in this ratio, etc. So if you have done those type of questions, these type of questions are very easy.
Sir, so the equation for this will be 81 is equal to X plus 1.317X.
I don't remember. I will have to see whether the equation is
Yes,
that.
sir. Be this only, sir. The final equation.
Okay, let me see. Let me see how to tackle this part. If this part is clear, then everything will be clear. Contains 31.7 more neutrons as compared to protons. So in those questions which I mentioned, that age is 5 years and younger than or older than, whatever is written after than, that was to be assumed. So in those questions, if it was something that Arjun is 15 years younger than, okay, uh, Balram. So Balram's age has to be assumed. Whatever is written after than, younger than. So this is something you will assume. Here also the same concept. And this is why I'm telling, because a few students face problem here. Which one to be assumed? 31.7% more neutrons as compared to protons means protons you have to assume. You will say assuming that we have X protons. Okay. Then N plus P is, then N will be, number of neutrons will be protons plus 31.7 divided by 100 of protons. Is that clear what I am saying?
yes,
Okay, it is 31.7% more. So I will add that much. So from here, I will get number of neutrons. And N plus P is given mass number, N plus P is given 81, that is N plus X is 81. And from here you will get 1.317x. So from here you got neutrons 1.317x, and from this one mass number is number of neutrons plus protons, you get N equals to 81 minus X. So equate these two, get the answer. Okay. So if you equate these two, 1.317x equals to 81 minus x, 1.317x plus x equals to 81, x equals to 81 divided by 2.317. Whatever you get, that will be the answer. I think you will get answer as here in this case 35. It is bromine. 23 Firuza, yes, that will be approximately. Is that clear? If any step is not clear, don't hesitate to ask. This is simple maths what I am talking about. Okay? Mass number 81 means number of neutrons plus proton is 81. 31.7% more neutrons means neutrons are number of protons, that is you can write just P if you want, and 31.7% more. So you got two relationships in N and P, between N and P. You have to get the atomic symbol. For atomic symbol, N plus P is already known. Atomic symbol is always like this. You need P. It means you need to eliminate N from these two equations and you will get the answer. Next one. An ion with mass number 37. Mass number is 37 and it is iron. Just see the difference. It was element, means it did not have any charge. So we were not bothered about charge. Here it is iron, so pay attention. Mass number 37. So if it is A, mass number is 37, this is 37, and 37 means what? N plus P is 37. Here you have P. So writing it as N plus P here, like this 37. But this is 1 unit of negative charge. 1 unit of negative charge means it has electrons, one more electron than the actual element. Iron has one more electron than actual element. That's why it has one. In normal, in normal element, number of protons is equal to number of electrons. But here, because it has one more electron, number of protons will actually be E minus 1. Why I am saying so? Suppose in a normal case, it has 11 electrons. If it is in elemental form, it will have 11 electrons, 11 protons. But if it is in ionic form, it has one extra electron, means it has 12 electrons, one negative charge. But protons will still be 11. It means protons are one less than electron, one less than electron. So there are various ways to do it or various ways to consider it. Okay, same question can be solved differently. Now come to here. If iron contains 11.1% more neutrons than electrons, it means you will assume electrons as X. You can assume electrons as X. So number of neutrons you can write, neutrons will be electrons plus 11.1% of electrons. This will be the relationship, means neutrons will be 1.111 X. So this is the first relationship you got. You can use this formula. Okay. And number of neutrons. Okay. In neutral atoms, number of electrons, sorry. In neutral atoms, number of electrons will be whatever number of electrons are there minus 1. Because in iron, number of electrons, we have assumed X. But if we are talking about the neutral atom, the number of electrons will be less. It means same will be number of protons, which I have already told you. Number of protons will be X minus 1. This is something we have talked about. Now you can apply the formula. Mass number is given as 37, means N plus P is 37. N from here is 1.111x and P from here is x minus 1 equated to 37. That's the answer. Means 2.111x will be equal to 37 plus 1, 8. X will be 38 divided by 2.111. So it will be less than 19. It will be approximately 18. 38 by 2 would have been 19. It will be 18. So if x is 18 and x we have assumed number of electrons in ion x, and if this is 18 means actual number of electrons would have been 17, or protons p will be x minus 1, that is 18 minus 1, that is 17, and 17 atomic number is of what? 17 atomic number is of chlorine.
Chlorine.
Okay. So it means the ion is chloride ion. So you will not write just Cl. You will write Cl minus, and then you will write its atomic number and mass. Mass number is given 37, atomic number 17 you have found. Don't forget to write this negative charge, otherwise you will lose marks. Any confusion, let me know. This is
Sir, can
mathematics
you
you have to
explain,
study.
sir,
Hmm.
can you explain uh, the bottom, the calculation part in which you took x minus 1, sir? Because, sir, I'm unable to understand which value of x, sir, you have operated. So, like, according to which.
Then why did we
You
take
can,
x minus 1? So
you
can please show me.
understand. In say I am talking about chlorine. Okay. So there will be 2, 8, and 7. This will be the configuration of chlorine. Chlorine. Elemental form means atomic form. But in the question it is given that it has one more electron. Okay. One electron more than the neutral atom means it will have the configuration of electrons, 8 electrons, and here also it will have 8 electrons. This electron is extra. This electron is extra. What you have done, you assume that number of electrons here in the ion is x. But you know that number of protons is equal to number of electrons in both, in elemental form, atomic form, this is ionic form. So if I want to calculate the number of protons will not be equal to x, because here it has one extra electron. Number of protons will be x minus 1, because number of protons will always be equal to electron in neutral atom here. Is that clear what I am saying?
Yes, sir.
In neutral atomic form, number of protons and electrons will be equal, but because I have assumed x number of electrons in ion, that's why I have to deduct one electron to get the number of protons. So from here I got p equals to x minus 1, and from the given equation that number of neutrons, okay, 11.1% more neutrons than electrons, I got this equation. So I got two equations from here. This gave me this equation, and one negative charge gave me this equation. And then I know that n plus p is the mass number, n I substituted from here, p I substituted from here. So I got the equation in terms of x only. Equation in one variable, solved it for x, and got the answer.
Sir, in this the neutrons are sir 11.1% more. So sir, is it for isn't it for the sir reduced number of protons, so like x minus 1, or sir it is upon the initial number that are present in the ions?
Ion, in the ion. It is written, ion contains. So that's why I have assumed electrons in ions, because I have to compare the electrons in ions.
Yes, sir.
Otherwise, answer will be wrong. An ion, again, with mass number 56 contains 3 units of positive charge. Positive charge means it has lost 3 electrons as compared to its neutral atom. Okay. And 30.4% more neutrons than electrons. Remember, we are talking about ion only. So whatever we will assume, that will be in ions only. We will do the same thing as we have done here. So you will say, first I am saying this one. So you will assume number of electrons. You will say assuming number of electrons in the ion equals to x, number of ions. Then number of neutrons n equals to 30.4% means x plus 30.4 by 100x. From here you got n equals to 1.304x. But in element, okay, or you can say if atomic number is p, or number of protons, okay, number of protons will be number of electrons in ion plus 3, because ion has lost 3 electrons. So I'm writing it so that there is no confusion. 3 units positive charge means ion has 3 electrons less than neutral atom. Negative parts have gone, that's why positive charge. Protons now 3 more, that's why protons will contribute to +3 charge. It means number of protons will be number of electrons in ions plus 3. This is in ion. This is in both atom or ion. Protons do not change. Protons same. Are you getting it? Why it is x plus 3, or any confusion? For
So yes,
example,
sir, because it's 3 units of positive charge.
yes, for example, if there is 13 atomic number and it loses 3 electrons, it will become Al3 plus, for
10.
example. Okay, Al3 plus, 10 electrons. It means actually there were 13, so you will have to add +3 to get the number of electrons in neutral atom. So that's why you added 3 in the electrons in the ionic form to get the total number of electrons in a neutral atom. In neutral atom, number of proton and electron will be equal. Okay. In neutral atom, number of protons and electron equal, but number of electrons in neutral atom will be x plus 3, 3 more than I. Now apply the same logic. Mass number is 56, means n plus p is 56. And substitute from here in terms of x, p from here, get the value of x. You will get n is 1.304x and p is x plus 3 equals to 56. And you need to solve it to get the answer. 56 minus 3 will be 53. So x actually will be 53 divided by So remember, whatever you get here, you will add 3. One very important point which is missed here, okay, which is I have told you in previous
Sir, on
question as well.
dividing, we obtain x is equals to 23 point something.
Okay, so approximately 23. Suppose it is 23. So if x is 23, it means number of electrons in the ion is 23. Number of electrons in the atom, that is protons. Protons will be x plus 3, means 23 plus 3. So you will say it means number of protons will be x plus 3, that is 23 plus 3 equals to 26. Atomic number will be 26, not 23. 23 is electrons in ions. Electrons in atom will be 23 plus 3, 3 more. If this concept is not clear, I would suggest that you pick your book of 9th standard, okay, where you started gaining knowledge about number of protons, number of electrons, number of neutrons, mass number, atomic number. Okay? And if you lose electrons,
Yes.
it is positive, that is cation. If it gains electrons, it is anion. So those concepts you need to revise from 9th standard. If you are facing problem here to understand this part, why it is x plus 3. So atomic number is 26 and atomic mass is approximately 56. That is mass number here. Okay. So 26 is atomic number of iron. So actually it will be symbol of iron. But how you will write it? You will write it 26 Fe 56 and don't forget to write 3 plus. Otherwise, marks will be deducted because question talks about iron. Charge has to be mentioned. Next question. Arrange the following types of radiations in increasing order of frequency. You remember I asked you to memorize at least, vaguely the frequency spectra, which will help you to arrange the radiations in increasing or decreasing order of frequencies or wavelength. So you remember that we had the cosmic rays here, then gamma rays, then we had X-rays, and then we had different types of, in ultraviolet rays, then we had visible region, then we had infrared region, then we had radio waves, etc. If you remember those things. Okay. So with that knowledge, you can have that the minimum frequency here will be of FM radio. FM radio will be here. Then it will be you have microwave radio. Microwaves.
So then traffic signal.
Then the traffic signal, because that is visible region, correct?
Yes, sir.
Then you have
So
visible.
X-rays and then
After that, you have
cosmic rays.
X-rays and you have
Cosmic.
cosmic rays. Now, in on many sites and books, it is written arrange following in increasing order, but still they write it in this order, which is yes correct, but it is actually decreasing order. It is not increasing order. The values are arranged in correct order. Cosmic rays frequency will be greater than X-rays, will be greater than visible region. Which is amber light. But you should write it like this because FM radio has the minimum frequency. So change the symbol. Microwave. Then it is amber light, visible region. But don't write visible region because it is given as amber light. And then X-rays, and then cosmic. This is logically correct because question is asking in increasing order. Although both answers are correct in the sense that the sign of greater than, less than is in right sequence. But this is a better way. Next, nitrogen laser produces a radiation at a wavelength of this if the number of protons emitted is this one, calculate the power. Now this question is not complete in itself. It is NCRT question. In latest edition also I have seen they have not changed it. We can calculate the power only if it is given per second. If they had written that photons emitted per second, then yes, we could have calculated power. Otherwise, whatever we get is the energy. And in this case, you need to calculate energy. That will be the answer. You can't calculate power. And E is equal to NHC by lambda. NH nu or NHC by lambda. All values we can substitute. Lambda is given, multiplied by 10 power minus 9, converted to meter. This number is given. H and C you will get the answer. Next, neon gas is generally used in the signboards if it emits strongly 616 nanometer. Calculate the frequency of emission. Wavelength is given, frequency you can calculate. Okay. Nu is equal to C by lambda. Distance traveled by radiation in 30 seconds. Distance traveled, you know that the velocity of light C is equal to 3 into 10 to the power 8. Okay, so in 30 seconds, in 1 second, this much. So in 30 seconds, 30 into this. Okay. So this is mathematics only. Energy. Yes. Energy of the quantum is h nu. Nu you have calculated, multiplied by h, c part done. Okay. So distance will be here in this case in 30 seconds, 3 into 10 power 8 into 30. That will be nice. Now D part, number of quanta present 2 joules ET is equal to N E. Okay. Means number of quanta is equal to total energy divided by energy of one photon. Total energy is 2 joules and energy of one photon you have obtained from here. Substitute. That's the answer. Any confusion you can ask if anything is not clear. Okay. And make sure that you are submitting assignments on time. Don't force me to have a PTM.
Sir, can you explain the D part once?
D part is total energy. It is actually similar to total area is equal to N into area of one tile. You have done these type of questions. Number of tiles multiplied by area of one tile will give you total area. Similarly here, total energy.
Yes, sir.
Total energy is equal to number of photons into energy of one photon. Means ET is equal to N E, where E is h nu. It is actually the same formula. H nu I have written as E. It is same thing. From here you will get N equals to total energy divided by energy of one photon. Next, in astronomical observations, signals observed from the distant stars are generally weak if the photon detector receives a total of this much joule from radiation of this much. So E is given, lambda is given, calculate the number of photons. Again, the same thing you have been doing. ET is equal to NH.
NHC by lambda.
Nu is, you will write C by lambda. Okay. ET is given, this is what you receive. Lambda is given, you convert it to meter. HC you know, N is unknown, you can calculate number of photons. Same formula, question is just phrased differently. Otherwise it is same thing. This question is again very easy, just lengthy words written to confuse you. Otherwise very easy, simple formula. Lifetimes of the molecules in excited state are often measured by using pulsed radiation source of duration nearly in the nanosecond range. And this sentence is not at all required in this question to solve this question. If the radiation source has the duration 2 nanosecond and the number of photons emitted during the pulse source is this much, calculate the energy of the source. Energy of the source is NhC by lambda or NH nu. If duration is given, radiation source has a duration of 2 nanoseconds.
Yes.
What is actually given here? What you
The
can
time
calculate from it?
Time
Yes,
period.
it is actually time period given. From this time period, you can calculate the frequency
Yes, sir.
and substitute here. Et is given anyway. No, number of photons is given. H you know, and from the time period, you can calculate the frequency. E is unknown, you will get the answer. Nu is actually 1 by T. You can write it 1 by T. And T is 2 nanoseconds, converted to second, 2 into 10 power minus 9. It will be 2.5 into 10 to the power 15 into 6.626 into 10 to the power minus 34 and 1 by 2 into 10 to the power minus 9. Next, the longest wavelength doublet absorption transition is observed at two wavelengths, 589 and 589.6 nanometer. Calculate the frequency of each transition and energy difference between two excited states. Again, very easy question. Lambda 1, lambda 2 are given. Lambda 1 is given 589 into 10 to the power minus 9 meters. Lambda 2 is given 589.6 into 10 to the power minus 9 meters. Okay. These are given. You have to calculate frequencies at associated. Nu is equal to C by lambda 1. Here, nu 1 will be C1 by lambda 1. Nu 2 will be C by lambda 2. You got the frequencies. And the energy difference will be E2 minus E1 H nu 2 minus H nu 1, that is H nu 2 minus nu 1. So that will be the answer. Next, the work function for cesium atom is 1.9 electron volt. Calculate the threshold wavelength. Now you need to understand whatever is related to work function is actually threshold. This is photoelectric material. Okay. And this is the incident beam will have E. Here you will use the energy. E naught will be used. Rest will be given as kinetic energy. Okay. So whatever is here is related to threshold. This is threshold energy. Related to this, the frequency will be threshold frequency. Related to this, whatever the wavelength we will calculate, that will be threshold wavelength. So whenever you get the word threshold, that is actually related to the work function. The threshold wavelength will be from here. E naught is given 1.9 electron volt, and you know that E is equal to Hc by lambda. E naught will be Hc by lambda naught. Threshold you need to suffix with naught to show that we are talking about threshold values. From here you will get the value of lambda naught. Make sure that you are using the correct values of energies and all the
Sir,
constants. Yes.
can we use lambda is equal to C upon V naught?
Yes, you can, but in this case, you know energy only. So how will you get the value of nu naught? You can use nu is equal to C by lambda. So nu naught will be C by lambda naught. But here in this case, we need wavelength from energy. So we have to use this formula. Otherwise, if it is required, you can use this formula also. Okay. That will be applicable. But here that is not applicable because energy is given. You have to use energy to get value of lambda naught. So lambda naught here will be hc by E naught. Make sure that you convert the value of E naught to joules. Otherwise, your answer will be wrong. Okay, threshold wavelength is required. So wavelength we have calculated hc by E naught. So I'm just substituting these values so that you don't make mistake. Lambda naught will be hc by E naught. That is 6.626 into 10 to the power minus 34, 3 into 10 to the power 8 divided by 1.9. It is electron volt. You will multiply by 1.6 into 10 power minus 19. Then it will be in joules. You'll get the answer. Okay. You can apply what you are saying. You can apply lambda naught equals to c by nu naught. In that case, you will first have to calculate nu naught, which is a lengthy process. Because first you calculate nu naught, then you substitute that value and then get the value. Here you can use directly with this one.
Sir, if we use work function, so V naught will be W naught will be equal to H V naught. We can use that to find,
That's what I'm saying. If you say W naught or E naught equals to H nu naught, then first you will calculate nu naught equals to E naught by H,
Yes, sir.
right? And then you will apply again formula lambda naught equals to C by nu naught. So you will substitute this value again here. That will be slightly lengthy process. Here
Okay.
you are just substituting all the values and calculating the answer in one step directly. So that will be two-step process, and you should avoid that. Way is correct, is not wrong, but lengthier way. The threshold frequency of the radiation. So here now it is asking, B is asking threshold frequency. So why to calculate first? First calculate threshold wavelength, which is asked A. Then in B you have been asked to calculate nu naught. This is something you can calculate by lambda naught. This is how you should do it. Nu naught equals to C by lambda naught. So you should use it now in B part. Lambda naught you know, C you know, 3 into 10 power 8, you will get the value. Now the question is, if the cesium element is irradiated with a wavelength 500 nanometer, calculate the kinetic energy and the wavelength. So from this, you can get the energy of the incident source. This lambda is given 500 nanometers. So you can calculate E from here. So E will be hc by lambda. H 6.626, C 3 into 10 power 8, lambda is given 500 into 10 power minus 9. So substitute these values, lambda, hc you know, you get the value of E. E naught is anyway given 1.9 electron volt. Kinetic energy is to be calculated. You can calculate kinetic energy. E you know from here. E is equal to E naught plus kinetic energy. Kinetic energy is E minus E naught. E you have calculated, E naught is given. Make sure that you use the right units. All units in joules, then you will get the correct answer. Or all units in electron volts, you will get the correct. Now, once you get the kinetic energy, you can calculate the velocity. Kinetic energy equals to half mv square. So all parts done. Next. And this is a slightly tricky question, so pay attention. Following results are observed when sodium metal is irradiated with different wavelengths. Calculate threshold wavelength and Planck's constant. So how you can use this data to calculate the threshold wavelength? For that, you need to, because you don't know the energy basically. Okay. So for that, don't just use one value. You have to use different equations. Okay. You have to form different equations and then get rid of the variables or constants. Fine? Variables or constants. So how you can use these things? You know the formula For threshold wavelengths, we know that E minus E naught gives you kinetic energy, or you can write equals to kinetic. Yeah. Velocity is given, but this value is actually when we multiply the value by 10 to the power minus 5, then you get 2.25. It means V will be, this V will actually be 2.55 into 10 to the power 5. Here velocity will be 4.35 into 10 to the power 5. Because this value is when actual value, this value has been multiplied by 10 to the power minus 5. So understand what I am saying. It means V will be 2.55 into 10 to the power 5. When we multiply it by 10 to the power minus 5, then we get 2.55, which is given here. So use the correct values. Sometimes you need to pay attention what is given here. It is not V, it is V multiplied by 2.55. So we will use this. How we use this? So for that, we will form the equation. Okay. How do we form the equations for that? We know that E minus E naught is equal to kinetic energy. That is, if I write Sc by lambda minus Sc by lambda naught, it is half mv square. I need to make use of both lambda and I don't know lambda naught. Lambda is given, v is given. Hc is constant. So take Hc out. Sc common. 1 minus lambda minus 1 by lambda naught equals to half mv square. We will use this to form three equations. We can form three equations using these. How we can form the equation? I'm writing just here so that I can use the space. 1 by lambda minus 1 by lambda naught equals to half mv square. So first I'm using this Hc 1 by 500 into 10 power minus 9 because it is in nanometer. 500 into 10 power minus 9 minus 1 by lambda naught, we don't know, equals to half m v square. V is 2.55 into 10 to the power 5. Now, when we say 2.55 into 10 power 5, it is centimeter. We have to convert it into meters. It is centimeter per second. It means it will be 2 to 10 to the power 7 meter per second and then whole square. I hope you understand what I am saying. All the units have to be in SI unit. Okay, in SI unit. Now, for simplicity, what I can say, I can consider that lambda naught is in nanometer also, and try to understand why I am saying so. Okay, it makes the calculations easier. That's why I am saying so. If lambda naught is also in nanometers, then it will be lambda naught into 10 to the power minus 9. If it is in nanometer, 500 into 10 power minus 9. If lambda naught is also in nanometer, lambda naught into 10 power minus 9. So we will consider lambda naught here in nanometers. So we converted that to meters by multiplying that 10 power minus 9. Why I did that? Because it will help me to take 10 to the power minus 9 common, and now it will be easier. 1 by 500 divided by 1 by lambda naught equals to 1 by 2 m 2.55 into 10 to the power 7 whole square. This question is slightly tricky. So pay attention because normally if it appears in good marks, 5 marks question. So either you get 5 marks or you lose 5 marks. So say this one is first. Similarly, form the second one from this part. From this part, it will be Sc divided by 10 to the power minus 9, 1 by 450 minus 1 by lambda naught equals to half m 4.35 into 10 to the power 7 whole square. second. Then similarly get the third one from here. HC divided by 10 to the power minus 9, 1 by 400 minus 1 by lambda naught equals to 1 by 2 m, 5.35 into 10 to the power 7 whole square. Say this one is third. You can use any two. Okay, so any two out of these three. 1, 2, 3. Divide HC by 10 to the power minus 9 will get cancelled. M will get cancelled. Only lambda naught will be the unknown. So you will get the value of lambda naught from there. Note down because you have to solve this question. Okay. You have to solve this question and send to me after the class.
So 1 minute, I'm noting it down.
Question number 52. You have these three equations formed. Now you have done in mathematics, you have solved these type of questions, how to get the value of lambda naught from here. So divide any one equation by any other one out of these three and get the value of lambda naught. Second is find the Planck's constant. After once you have obtained the value of lambda naught, substitute the values of the speed of light, okay, mass of electron, lambda naught in any one equation, and you will get the value of h. Okay, don't just write value of h as 6.626 into 10 power minus 34 because in such cases the value will be slightly different. So whatever value you get, that will be the answer. But it will be very much close to 6.626 into 10 power minus 34.